Alright, so this video is going to outline how to create an isotope symbol for any given isotope. So usually, again, like the practice we were doing in class, what we're going to do is we're going to start with an isotope name, something I've given you, and then we'll go from there. So let's go ahead and get started with this first one, carbon-14. Carbon-14, if you remember the article that we read in class last week about carbon dating, this is that isotope of carbon that is radioactive and falls apart. So let's go ahead and create an isotope symbol for it. So the first thing we need to do is we need to look at the name. Okay, so we're going to look at and find carbon on the periodic table by just looking for its name, and then we need, what we're looking for is its symbol. So if we find carbon, carbon's right here, number 6. And so the symbol for carbon is big C. So if I go ahead and go down here, if I wanted to start this isotope symbol, I would just draw a nice big C for carbon. Okay. Then the next step, we're going to take the mass number that's in the name of the isotope, and we're going to put it right at the top of the isotope symbol over here off to the left. So if it's carbon-14, we're going to put a 14 up here at the top. Okay. Then the next step is we're going to run up here again to the periodic table. We're going to find carbon again, and we need to figure out how many protons there are in carbon. So if I look at carbon in the top left corner, there are 6 protons in carbon. So if I go back over here, down at the bottom below the 14, I'm going to draw a 6. Okay. So this is the isotope symbol for carbon-14. All right. And so the reason why we write it like this is because we want to be able to figure out what all makes up this carbon-14 atom. Okay, so if we go back through and remember, all right, the 6 came from the periodic table, and that tells us the number of protons. So if I wanted to know what this atom looks like, I could start off by saying it has 6 protons. Okay, and then we know that if it's uncharged, the whole atom is usually neutral. If we've got 6 protons, which are positive, then it also has to have 6 electrons. Okay, and so we've got our protons and our electrons, so that means we really only have one more piece to this. And so the way we figure that out is we just the reason why we set this isotope symbol up this way, so we can subtract. So if we have an overall mass of 14, so if carbon weighs 14 AMU, and 6 of those AMUs are protons, then that means whatever's left has to be neutrons. So if we take 14 minus 6, we get 8. And so that tells us that we have 8 neutrons. So this atom, we could now draw it if we wanted to. We won't do that since that's covered in another video, and we also did that in class together. Okay, but that atom would have 6 protons in the nucleus. We'd have 6 electrons going around the outside, and then with those protons in the nucleus, we would have 8 neutrons. Okay? All right, so let's do another example. Let's look at iron. All right, so iron-57, we want to write the isotope symbol. So again, the first step is we're going to go up to the periodic table, and we're going to find iron. So iron is right here, number 26, and its symbol is Fe. Okay, and so remember how we talked about how element names and symbols are a little different because a lot of these symbols come from their Greek or Latin names. And so iron has its Latin name is ferrous, and so that's why its symbol is Fe. So we're going to go ahead and go down here to the bottom, and we're going to write Fe. Okay? And then we're going to take the mass number that's in the name of the isotope, and we're going to go ahead and write that up top. So this iron atom weighs 57 AMU. Okay? And then if we go back up to the periodic table and look again at iron, it's number 26, which means it has 26 protons. Okay? So if I wanted to go down and record protons, neutrons, and electrons, I'm just going to write P this time. So it has it has 26 protons, okay, which means it also has to have 26 electrons, okay, and then in order to figure out how many neutrons it has, we'll go ahead and subtract, okay. So if we subtract these, we should get 31. And so this isotope of iron has 31 neutrons. So let's do one more together real quick. So sodium, okay, we're going to go through this one a little faster. So sodium on the periodic table is going to be over here off to the left. Okay, so if we look, it's right here. All right, so the symbol is Na, and then it's number 11. So let's keep that number 11 in mind too as we go back and write our isotope symbol. So let's start with the Na for sodium. It's sodium 22, which means that overall it weighs 22. Okay, and it has 11 protons. So again, if I wanted to go ahead and record protons, it's got 11 of them, which means it also has to have 11 electrons. Okay, and then in order to figure out how many neutrons it has, if I subtract them, this time we get 11. So this atom is nice and evenly balanced. It's got 11 of everything, 11 protons, 11 neutrons, and 11 electrons. Okay? So hopefully now you have a better understanding of how to write isotope symbols and then how to use those isotope symbols to figure out what are the different parts of this atom and how many of each of them do we have. So, all right, best of luck, and we'll see you at class.